All right, here we go with part 4. I'm going to change up a little bit and do this on paper because I want to be able to refer to these graphs so that you can actually see them. The first question, what family of functions does g belong to? And this is an absolute value function. You need to make sure that you know your basic functions. Absolute value function, quadratic function, cubic function, cube root function, all the different functions that we looked at when we were doing functions at the very beginning. If you look back, there it's posted as well, but there was a handout that had the different parent functions. So know what those are. The basic function here is going to be f of x equals the absolute value of x. Identify the transformations in the correct order. R, S, T. We do reflections, then we do shrinks and stretches, then we do transformations. So this thing is reflected, right? Because it's coming down, so that's going to be reflection about x. You could also call that a vertical reflection, right? Remember, because we reflected about the x-axis. As far as the shrinking goes, we look and we go and start at the origin point, or what would be the origin. We go over 1, down 2. So that means that we have a vertical stretch of factor 2. So when we go over, we go, instead of over 1, up 1, it's over 1, down 2. Now the down was dealt with the reflection, but the fact that it's 2 is what makes this a stretch. Finally, our transformation, this is going to be left 1, up 2. So to write the equation for g, anything that happens horizontally happens inside the absolute value. So we are horizontally just moved left 1. So that's going to be x plus 1, not minus. The vertical stretch of factor 2 puts us there. Since it is, the up 2 gives us a plus 2 out there on the end. The vertical stretch puts the 2 out. The reflection about x makes that negative. And there we are. Done. Next we have this graph where we have the blue function is f of x, the red function is g of x, and we are going to combine these functions in a couple of different ways. So we do f plus g of negative 3. So we see that f of negative 3 is 1, g of negative 3 is negative 2, 1 minus 2 is negative 1. F of 0 is negative 2. G of 0 is positive 1. But we are subtracting, so negative 2 minus 1, that would be negative 3. F times g of 0, well, we already have the two values. F we said was negative 2, g is 1, negative 2 times 1 is negative 2. F divided by g of 0, that would be negative 2 divided by 1, so that's also going to be negative 2. F divided by g of negative 1, so f of negative 1 is negative 3. G of negative 1 is 0. Negative 3 divided by 0, not okay, does not exist. F of g of 0 is 1. So that would be the same thing as f of 1. And f of 1 is 1, so that's 1. So again, what I did there is I found g of 0 first. G of 0 is 1. Then we take that and we plug it into f. And f of 1, that's also 1. Same idea here. F of negative 3 is 1, and then g of 1 is 2. Vertex form of f of x, so that's going to be A is 1 here. We start at the vertex. We go over 1, up 1. So that means that our A is just 1. Then our vertex, remember the vertex form is A times x minus h squared plus k, where hk is the vertex. So in this case, my A value is 1. My h, which is the x value of the vertex, is negative 1. So that's going to be x plus 1 squared. And then my k value of the vertex, that's negative 3. So that's going to be x squared, x plus 1 squared minus 3. Slope-intercept form of g of x, it intercepts at 1, up 1, over 1. So that is just x plus 1. Next, we're going to analyze this graph. We're going to look at, in order, domain. These are the x values. So we start at negative 5. We are including negative 5 because that is a closed point. That is why I used a bracket. And then the arrow says that that's going to go on forever. Range, the highest value that we have is at 4. Then we come down. And again, because we go on forever, that's going to be, oh, I messed up there. All right, the lowest value we take actually comes from down here. All right, so looking at the y's going from smallest to largest, hold on just a second. There we go. All right. The y's start at negative infinity, and then it comes up and up and up and up and up and up, and the highest it ever gets is at 4. And it does include that 4, so we use a closed circle. We have zeros at negative 1, 1, and 3. So negative 1, 0, 1, 0, and at 3, 0. Relative minimums, we only have 2 relative minimums. We have a relative minimum at negative 4, and that is at the point 2. And then we have another relative minimum at negative 2, 0. Relative maximums, that's going to be at the point negative 3, 3. And then we have another relative maximum at 2, 1. As far as absolute minimum, that does not exist. The absolute maximum is this point right here, and it does exist because that is a closed circle, so that's at negative 5, 4. My intervals of increase, remember this is if I'm riding a bike, I'm going uphill. We never include the actual peaks. So going uphill, I'm going uphill from negative 4 to negative 3. Then I'm going uphill again from 0 to 2. And those are my only 2 uphill pieces. My decreasing, I'm starting at negative 5. Even though that is a closed circle with intervals of increase and decrease, we never include that boundary point. So we're going to go from negative 5 to negative 4. Then we're going to decrease again from negative 3 to 0. And then we're going to decrease again from 2 out to infinity. This is a function. It passes the vertical line test. Plugging in values, f of 0 is negative 2. F of negative 2 is positive 2. F of 5 is negative 4. When is this greater than 0? Well, it's greater than 0 from its beginning point, which is negative 5. So these are intervals from negative 5. Greater than 0, greater than 0. Ooh, right there at negative 1. We do have or equal to, so we'll include that negative 1. Then in this little interval between negative 1 and positive 1, we are below the x-axis. So we become positive again at 1. And we stay positive until we get to 3. and then we go on negative forever. So those are the two intervals where we are greater than 0. Finally, where is f of x equal to 5? It's not equal to 5 anywhere. 5 is outside of our range. Alright, so there's your review for the final exam. There'll be more stuff posted. I've given you a comprehensive review that you should be working on. Please do so. It also has a key associated with it. I have posted the key for this assignment as well. So good luck and good studying.